The morning of June 22, 1944, in the Norman Bocage southeast of Caen, a German reconnaissance patrol discovered something that would puzzle their battalion commander. For weeks, among the equipment scattered across an abandoned American defensive position, lay a distinctive canvas-wrapped device. It was roughly the size of a large field pack, constructed of weathered olive-drab metal and canvas webbing. Inside the pack was an intricate assembly of vacuum tubes, transformers, and copper wiring. The device had a leather-carrying strap, a handset connected by cloth-wrapped cord, and a frequency dial marked with unfamiliar calibrations. The German soldiers who found it had no immediate sense that this object represented a fundamental shift in how warfare would be conducted. It was simply equipment captured from the Americans. It was photographed, catalogued, and sent up the chain of command. Within days, it reached the hands of German signals officers who understood immediately what they were looking at. It was an American field radio, not a portable radio those had existed for years. This was something more refined, more capable, and far more dangerous than anything the Wehrmacht possessed. If you enjoy untold stories about how technology changed warfare, please like this video and subscribe. We explore the hidden engineering stories behind history's greatest conflicts. New episodes every week. The radio was the SCR-300, manufactured by the Signal Corps Radio Laboratory. The designation stood for Signal Corps Radio, and the 300 indicated it was the 300th experimental design in the series. But this was no longer experimental. By 1944, the SCR-300 was standard issue throughout the United States Army. The device would become one of the most consequential technological advantages in the Second World War, transforming how infantry communicated with artillery and air support. To understand why German officers were so stunned by this captured radio, one must first understand how communication worked in the Wehrmacht. The German army had developed sophisticated signals doctrine over decades. The Heer maintained extensive telephone networks in rear areas, using field telephone wires strung between positions. These networks were reliable and secure, but they were only useful for positions that remained static. Once the army was moving, once combat became fluid, the telephone networks became useless for mobile communication. The Wehrmacht relied on the Funkgerät system field radios that operated on lower frequencies and were considerably larger and heavier than the American SCR-300. The standard Wehrmacht infantry radio was the Feldfernsprecher, a combination telegraph and telephone system that required extensive setup time. There was also the Funksprecherät, a voice radio, but it was bulky, required 2 men to operate effectively, and had limited range. Even more problematic, it operated on frequencies shared with other units, which meant communication was often jammed by interference from other transmitters. In the same geographic area, German infantry tactics reflected these communication limitations. An attack would be planned in detail before it began. Officers would brief their men on the entire sequence of the assault. If conditions changed during the attack, if the enemy position proved stronger than expected, if reinforcements were needed, there was no reliable way to communicate that information quickly. The attack would proceed as planned, even if the plan was proving disastrous. German artillery operations faced similar constraints. Artillery was positioned miles behind the front lines. Observers with the forward infantry could request fire support, but the process was slow. An observer would use a field telephone to contact his regiment's signals section. The signals section would relay the request through the telephone network to the artillery battery. The battery would plot the coordinates, aim the guns, and fire. The entire process could take 30 minutes or longer during a fast-moving engagement. 30 minutes was an eternity. Enemies could advance, dig new positions, or withdraw entirely. American doctrine, by contrast, had evolved differently. American commanders understood that modern warfare required rapid communication. Infantry needed to talk to artillery. Artillery needed to talk to air support. Different units needed to coordinate movements in real time. The SCR-300 had been designed specifically to fill this role. The radio had been in development since the late 1930s. American signals engineers understood that future wars would be mobile wars, requiring tactical communication that could move with the troops. The SCR-300 was the result of years of refinement. It weighed approximately 38 pounds with the battery pack, roughly the same as the total weight of a German infantryman's rifle, ammunition, and pack combined. The radio could be carried by a single soldier designated as the radio operator, though in practice, two men typically shared the load, one carrying the radio itself, another carrying spare batteries. The SCR-300 transmitted and received on frequencies between 30 and 38.9 MHz. This was the VHF very high frequency spectrum. The higher frequencies offered significant advantages over the low frequency systems the Germans used. Higher frequency transmissions had shorter range, but much better clarity. They were less susceptible to atmospheric interference. Most importantly, they were more resistant to jamming. A German radio operator trying to jam an SCR-300 transmission would need to jam a much narrower frequency range, and the American operator could shift frequencies quickly to find clear channels. The radio had a range of approximately 3 to 5 miles in clear terrain, somewhat less in urban or heavily forested areas, but for the distances involved in infantry to artillery communication, usually between 1 and 3 miles, this range was more than adequate. The device used vacuum tubes rather than solid-state transistors, which would not become available until after the war. Vacuum tubes were more fragile than later technology, but they were rugged enough for field use. The radio had been tested extensively in field conditions. It could function after being dropped, after exposure to mud and water, after days of continuous operation. The SCR-300 came in a canvas pack that soldiers carried on their backs. The antenna was a simple 6-foot rod that could be extended upward or laid flat. To reduce the radio's profile, operation was relatively simple. The radio operator would extend the antenna, tune to the correct frequency, and use the handset to transmit. Most importantly, the radio allowed real-time voice communication. Officers could speak directly to their subordinates. Artillery observers could request fire immediately, speaking directly to the fire direction center. The entire process of requesting fire support, which could take 30 minutes with a telephone system, could be accomplished in 2 or 3 minutes with the SCR-300. American artillery doctrine had been fundamentally restructured around this capability. Forward observers officers and enlisted men positioned with the infantry carried SCR-300s linked directly to the battery's fire direction center. The observer would spot a target, range it quickly using binoculars and map reading, and immediately transmit fire commands. Within minutes, artillery rounds were impacting the target. This was something the German army simply could not do. German artillery doctrine still relied on the assumption that targets would be planned. Before the battle began, the guns would fire on predetermined coordinates. They would shift fire according to a prearranged timetable. If something unexpected happened, if American troops appeared in an unanticipated location, German artillery could not respond quickly. The American observer with an SCR-300 could dot by June 1944. Every American infantry company had at least one SCR-300 radio. Larger units had multiple radios operating on different frequencies. This created overlapping networks of communication. An infantry platoon could talk to its company. The company could talk to the battalion. The battalion could talk directly to artillery. Artillery could communicate with their support. Officers at every level knew what was happening in real time. When the Allies invaded Normandy on June 6, 1944, German commanders were immediately aware that something was fundamentally different about American communications. American troops would attack, and German positions would be saturated with artillery fire within minutes. German artillery would attempt to respond, but by the time they registered on the American positions, the Americans had already called in more fire or had withdrawn to new positions. The speed of American communication was creating a tactical advantage that German officers could observe but could not explain. How were the Americans adjusting fire so quickly? How did they know where to move next? How could they concentrate artillery so rapidly on dispersed targets? The answer, captured in that canvas-wrapped pack in the Norman Bocage, was the SCR-300. German signals officers who examined the captured radio immediately recognized its superiority to anything the Wehrmacht possessed. The German army had radio technology, but nothing like this. The SCR-300 was smaller, lighter, more reliable, and far easier to use than German equivalents. Most importantly, it was mass-produced. The United States had manufactured tens of thousands of SCR-300s by 1944. German signals officers submitted detailed reports to Wehrmacht High Command. The reports documented the technical specifications of the radio. They noted its frequency range, its effective range, its power requirements. They analyzed its construction, identifying the specific components used. They assessed the tactical implications. One report, classified as highly confidential, concluded that if German infantry had access to equivalent communication capability, their tactical flexibility would be dramatically improved. But the German army faced the same problem that had plagued every attempt to match American technological advantages. Designing a radio was one thing. Manufacturing thousands of them while fighting a two-front war was another thing entirely. Germany had radio manufacturing capability. The company Telefunken produced radios for the German military, but Telefunken was already operating at maximum capacity, producing radios for the Luftwaffe, for naval vessels, and for other military applications. German strategic materials were becoming increasingly scarce. Copper, essential for radio construction, was needed for ammunition casings, for electrical wiring in aircraft, for countless other military applications. German factories were being bombed regularly. Production was being disrupted. Adding a new high-priority radio program to this environment was nearly impossible. German signals officers requested authorization to begin producing copies of the captured SCR-300. The request moved up through Wehrmacht channels. It reached the High Command. The response was typical of late-war German decision-making. It was deemed impractical. Germany would focus resources on weapons already in production. German signals doctrine would need to adapt to the reality that American troops had better communication. What German commanders did not fully grasp was that communication was not a peripheral advantage. It was not something that was nice to have. It was becoming central to how battles were won and lost. American artillery batteries in Normandy were firing ammunition at a rate that would have been impossible to sustain without the SCR-300. An artillery battery firing without real-time targeting information would fire on predetermined coordinates, expend their ammunition, and fall silent. An artillery battery receiving real-time targeting information from SCR-300 operators could keep their guns firing continuously, shifting targets instantly, concentrating fire on whatever American infantry commanders identified as critical. The result was an overwhelming advantage in firepower delivery. German infantry attacking American positions would be surprised by the speed and intensity of artillery response. German defensive positions would face artillery fire that shifted and concentrated with terrifying precision. By midsummer 1944, German officers were filing after-action reports documenting this tactical reality. American artillery seemed to have unlimited ammunition and could deliver it with uncanny accuracy. The reports attributed this to superior American supply lines and superior American artillery techniques. Few reports directly credited the SCR-300, primarily because most German officers had never seen one and did not fully understand what it was. The strategic implications were vast. The United States was fighting with a technological advantage that accelerated every aspect of mobile warfare. Infantry with SCR-300s could advance faster because they could call artillery support immediately. Artillery could concentrate fire more effectively because forward observers could provide real-time target information. Air support could be coordinated more effectively because ground units could communicate directly with pilots. Every element of the American war machine was more tightly integrated, more responsive, and more lethal because of radio communication capability. The Germans possessed excellent infantry soldiers, excellent non-commissioned officers, and excellent engineers. German tactical doctrine was sound. German armor was competitive with American armor. But the integration of all these elements depended on communication, and in communication, Germany was fundamentally behind. This was the reality that German commanders faced in Normandy in summer 1944, and it was a reality they could not easily change. The battle for Normandy illustrated the advantage repeatedly. American forces would advance, and German commanders would attempt to counterattack. The counterattacks would be coordinated by radio, with German regimental and divisional commanders directing multiple units across a dispersed battlefield. But the coordination was slow. It relied on couriers and field telephones that were constantly being cut. By advancing American troops, meanwhile, American forces would request air support, and within 20 minutes, fighter bombers would be striking German positions. American infantry would call for artillery, and rounds would land within minutes. The difference in response time was creating a gap in tactical effectiveness that was widening every day. By late June 1944, German signals intelligence had captured multiple SCR-300s from destroyed American units. The Wehrmacht's signals research establishment, the Heeresfunkprüfung, conducted detailed analysis. The researchers disassembled the radios completely, cataloged every component, and tested their performance characteristics. The findings were documented and classified. Reports that circulated among Wehrmacht High Command. The reports made clear that the SCR-300 represented a fundamental technological advantage that Germany could not quickly replicate. The radio required precision manufacturing. The vacuum tubes had to be manufactured to exacting specifications. The frequency crystals had to be cut to precise tolerances. The variable capacitors, transformers, and other components all required machinery and materials that Germany was increasingly unable to provide. Most critically, manufacturing the SCR-300 required specialized industrial capacity. The United States had dedicated entire factories to radio production. These facilities employed thousands of workers trained in precision electronics manufacturing. Germany had nothing equivalent. Creating such capacity would require months of construction and tooling. Assuming the necessary materials were available, which they increasingly were not, German signals officers made the practical decision to stop requesting authorization for SCR-300 production and instead focus on understanding how to defeat the radios tactically. If they could not match the technology, perhaps they could jam it, intercept it, or disrupt it through other means. German electronic warfare specialists began studying the captured radios with this objective in mind. The SCR-300, like all radio equipment, had vulnerabilities. It operated on specific frequencies. If you knew the frequencies, you could attempt to jam the transmission. But the American radios had multiple frequencies available, and operators could shift frequencies quickly. Jamming one frequency would simply cause the operator to switch to another. The radio's antenna was a critical vulnerability. If the antenna was damaged or blocked, the radio's range would be severely reduced. German forces began training soldiers to target radio antennas. Whenever they encountered American infantry, a sniper could attempt to shoot the antenna rod. Artillery could target the general area where radio operators were likely to be positioned. But these were tactical workarounds, not solutions. They did not close the fundamental gap. A German regimental signals officer named Hauptsturmführer Wilhelm Kessler submitted a report in July 1944 that captured the frustration of German command. The report noted that American infantry units were operating with a level of coordination and responsiveness that German units could not match. American artillery was delivering fire with a speed and accuracy that suggested real-time targeting information. American tactical movements were synchronized in ways that implied immediate communication across dispersed units. The report concluded that the SCR-300 was the key to American tactical superiority. The radio allowed American commanders to exercise control over dispersed units in a way that German commanders, relying on field telephones and couriers, simply could not. The report recommended that Germany prioritize the development of equivalent radio technology, but the recommendation died in the bureaucracy. By summer 1944, German military production was being disrupted by bombing. Raw materials were becoming critically scarce. and the Eastern Front was demanding increasingly desperate resource allocation. The focus on developing new technology was replaced by the focus on simply maintaining production of existing weapons. The SCR-300 remained an American advantage that Germany could observe, but not match. The tactical implications became increasingly apparent as the Normandy campaign progressed. American forces were not advancing through superior tactics alone. They were advancing through superior firepower delivery. When American infantry encountered German defensive positions, they could immediately call artillery to soften those positions. German defenders would face incoming fire that arrived with shocking speed. By the time they had sent runners to battalion headquarters requesting artillery support, American guns were already impacting their positions. In one engagement near Saint-La in mid-July 1944, an American rifle company encountered a German defensive line anchored on a hedgerow. The Germans had machine guns, anti-tank guns, and infantry in prepared positions. Under normal circumstances, this would be a difficult position for the Americans to attack. The company commander, a captain named Robert Hayes, ordered his men to take cover in the hedgerow across from the German position. Instead of attacking immediately, Hayes radioed the battalion's forward observer, who was positioned a half-mile to the rear with a direct radio link to the divisional artillery. Hayes transmitted target coordinates and a brief description of the target German machine gun position and hedgerow. The forward observer acknowledged the transmission and immediately called the artillery battalion for a direction center. The fire direction center received the transmission, verified the coordinates, and radioed fire commands to the artillery battery. Gun crews loaded shells into the breaches. The first round landed 100 meters beyond the target. The observer adjusted the fire. The second round was closer. The third round impacted directly on the German position. Within minutes of Hayes's initial request, artillery fire was striking the German defensive line. German soldiers in the position heard the incoming rounds seconds before the first shell impacted. They had no idea where the fire was coming from. They had not received any indication that artillery was being called. From their perspective, the American infantry had simply spoken into a radio, and fire from the sky had appeared. German soldiers began taking cover, attempting to protect themselves from the shelling. When the shelling stopped, American infantry assaulted the position. The Germans were still in disarray, still recovering from the artillery bombardment. The American attack succeeded with minimal casualties. The German defenders were killed, wounded, or captured. The American infantry occupied the position. This sequence: identify target, call for fire, receive fire. Assault could be accomplished in less than 10 minutes with the SCR-300. Without it, the process would have taken 30 minutes or longer, if it was possible at all. This pattern repeated across the Normandy battlefield throughout summer 1944. German commanders filed report after report describing American artillery that responded with uncanny speed and precision. Some German officers attributed this to superior American gunnery. Some attributed it to vast American ammunition supplies. Few fully grasped that the speed of communication was the fundamental advantage. American artillery was not firing more ammunition per gun than German artillery. American guns were not inherently more accurate, but American guns were firing at targets that were being identified and transmitted to them in real time. Every shot was directed at an active threat. There was no wasted fire on predetermined coordinates or on targets that had already moved. This efficiency in firepower delivery was devastating when applied across the entire battlefield. By August 1944, German forces in Normandy were in retreat. American and British forces had broken out of the bocage and were advancing rapidly through France. German commanders attempted counterattacks, but these counterattacks were repeatedly detected by American scouts, who called in artillery strikes before the German attack could develop. American air superiority was making movement during daylight increasingly difficult. American tanks were advancing faster than German reserves could be rushed to counter them. German commanders would later identify the failure of German signals technology and the success of American signals technology as key factors in the German defeat in Normandy. A post-war analysis by German General Hans von Luck noted that American command and control was vastly superior to German command and control, and that this superiority was primarily a function of superior communication equipment. The implications extended far beyond Normandy. American forces advancing across France in late 1944 were operating with communication capabilities that allowed commanders at battalion level and above to maintain real-time awareness of what was happening across a dispersed battlefield. German forces were still operating with 19th century communication technology. Field telephones and couriers applied to 20th century warfare. The advantage this created was not easily quantifiable. You could not point to a specific moment and say, the SCR-300 won this battle, but you could measure its impact in multiple ways. American casualty rates, particularly among infantry, were consistently lower than German casualty rates in equivalent engagements. This was partly due to American armor superiority and partly due to American air superiority, but a significant portion was due to the ability to call artillery support quickly. American artillery was being used much more efficiently than German artillery. German artillery would expend ammunition on bombardments of predetermined targets, many of which were no longer occupied. American artillery would concentrate fire on targets identified by forward observers in real time. The result was that American artillery was achieving far higher target hit rates and causing far more damage per round expended. American infantry movements were being coordinated across larger areas with greater precision than German movements. A battalion commander could maintain control over his troops, even when they were spread across several miles and operating in terrain where visual contact was impossible. German battalion commanders faced the same challenges, but lacked the communication technology to maintain the same level of control. These advantages compounded over time. As American forces advanced, they were able to maintain coherent operations across increasingly dispersed areas. German forces were increasingly unable to coordinate their own movements and were consequently outmaneuvered repeatedly. The SCR-300 was not the only reason for this, but it was a significant factor. The radio's advantage became even more pronounced when combined with American air superiority. As American forces advanced into Germany itself in early 1945, the SCR-300 took on additional importance. Infantry units advancing ahead of armored columns needed to request air support constantly. German counterattacks needed to be detected and reported so that fighter bombers could be directed to strike them. All of this required rapid communication. American air liaison officers stationed with advancing ground units carried SCR-300s. They could contact the forward air controller, who could immediately direct aircraft to targets. The process from target identification to aircraft arrival could be accomplished in 15 to 20 minutes. This responsiveness meant that German reserves attempting to counterattack were often detected and struck by air power before they could even reach the American lines. The SCR-300 represented one of those rare technological advantages that was not decisive in itself, but became increasingly decisive as the war progressed and the military situation changed. In the static trench warfare of World War I, superior communication would have mattered less. In the mobile warfare of World War II, where armies were advancing hundreds of miles and engaging in rapid maneuver, superior communication was invaluable. The German army attempted to compensate for the SCR-300 through superior tactical training and superior leadership at lower levels. German non-commissioned officers were exceptionally well trained. German infantry tactics were sophisticated and effective. German soldiers fought with discipline and courage. These qualities allowed German forces to continue fighting effectively, even when they were losing the broader campaign. But these qualities could not overcome the fundamental disadvantage in communication technology. A German soldier or officer could be an excellent tactician, but if he did not know what was happening 2 miles away, if he could not request support from units outside his visual range, if he could not coordinate with other units except through couriers that took hours to deliver messages, then he was at a disadvantage against an American officer with a radio. German attempts to develop equivalent communication technology were too little and too late. German radio research continued throughout 1944 and 1945, but the projects were underfunded and disrupted by bombing. A German VHF radio designated the Feldfernsprecher Type EK was developed, but never produced in significant quantities. German assault gun units attempted to use captured SCR-300s, but this was impossible because the radios operated on frequencies that only American forces knew. The closest Germany came to matching American communication capability was the Funksprecher, but this radio was heavier, less reliable, and had shorter range than the SCR-300. Even if German forces had possessed equivalent radios, German doctrine and training were not structured around rapid radio communication, the way American doctrine was. It would have taken years to retrain German officers and soldiers to use radio communication effectively. By early 1945, as American and Soviet forces closed in on Germany from east and west, the communication gap had become absolute. American forces advancing into Germany were operating with real-time communication that allowed them to coordinate across hundreds of square miles. German forces were attempting to conduct a desperate defense using 19th century communication technology. The outcome was never really in doubt. The final battle in Europe demonstrated the advantage one last time. The Ardennes Offensive, launched by Germany in December 1944, relied on surprise and rapid movement. German forces attempted to punch through American lines and advance to the sea, cutting off American and British forces from supplies and reinforcement. The offensive initially achieved tactical surprise. German forces penetrated American lines and began advancing westward. But American forces rapidly reorganized and began counterattacking. American units requested air support, and within hours, the skies were filled with American fighter bombers attacking German columns. American artillery was concentrated on German positions with devastating effectiveness. German counterattacks were detected and reported through the SCR-300 network. Artillery was immediately directed to strike the attackers. American reserves were rushed to threaten positions with coordination. That would have been impossible without radio communication. The Ardennes offensive failed, not because German soldiers fought less bravely, but because the American command and control system was simply superior. American commanders knew where the German attack was developing, could concentrate their response rapidly, and could coordinate air, artillery, and ground forces with precision. German commanders were attempting to control their attack through runners and field telephones while their forces were being struck. By air power they could not defeat, and artillery they could not suppress the SCR-300, along with the American doctrine that had been built around it, proved to be one of the most consequential advantages America possessed in the European theater. It was not as visible as tank armor or artillery firepower. It did not fire bullets or launch shells, but in enabling American commanders to exercise control over dispersed forces in real time. It transformed how modern warfare could be conducted. German officers who survived the war and later reflected on their defeat, CONSISTENTLY identified communication technology as a critical gap. German General Adolf Strauss noted in a post-war interview that German forces in the final months of the war were often unaware of what was happening just a few miles away, while American forces maintained constant awareness across their entire operating area. This awareness, he argued, allowed American forces to respond rapidly to German movements, concentrate forces at decisive points, and avoid being surprised by German counterattacks. The SCR-300, more than any other piece of equipment, enabled this awareness. The war in Europe ended in May 1945. When American forces occupied German territory, they discovered extensive documentation about German attempts to understand and counter the SCR-300. German signals officers had submitted detailed technical reports. German military researchers had conducted analysis of captured radios. German High Command had debated whether to prioritize radio development. The conclusion was always the same: Germany could not match American production capacity. German industry was stretched beyond its limits. By 1945, German factories were operating under constant bombardment from American air forces. Raw materials were critically scarce. The labor force was depleted by military conscription. There was simply no way to add a major new weapons production program, even if the technology had been available years earlier. American technical teams found approximately 30 captured SCR-300s in German arsenals. When the war ended, some were intact, having been studied but never operationally deployed. Others were partially disassembled, with German engineers attempting to understand how they worked. The radios were shipped to the United States for analysis. American military planners studied the German technical reports and were struck by how clearly German signals officers had understood the problem and how unable they had been to solve it. The post-war analysis of German signals capabilities formed part of the broader assessment of why Germany had lost the war. Military historians and officers consistently identified the communication gap as a significant factor. American forces had maintained superior coordination, superior command and control, and superior tactical responsiveness. German forces had been unable to match these capabilities, despite having excellent soldiers, excellent officers, and solid military doctrine. The lesson was not lost on American military planners. The SCR-300 had proven its worth. It would remain in service long after the war. The radio would be used throughout the Korean War and would continue in service with some units into the 1960s. More importantly, the success of the SCR-300 validated an approach to warfare that would define American military doctrine for decades. The United States recognized that in modern warfare, communication was as important as firepower. An army that could talk to itself faster than the enemy could talk to itself would have an overwhelming advantage. American military planners invested heavily in communication technology. In the decades following World War II, radio communications became more sophisticated, more reliable, and more integrated into tactical operations. The Soviet Union, observing American advantages in communication, attempted to match them. Soviet military doctrine evolved to emphasize rapid communication and centralized control. The communication advantage that America had possessed in 1944 was harder to maintain. By 1955, as other nations developed comparable technology, but the principle remained valid. The ability to transmit information rapidly from front-line soldiers to commanders, to coordinate artillery and air support, to maintain awareness of a dispersed battlefield. These capabilities remain central to military effectiveness. The SCR-300 had demonstrated that principle more clearly than any other weapon system of World War II. The tactical implications extended beyond the European theater. American forces in the Pacific had also operated with SCR-300s, though the role of the radio was somewhat different in jungle warfare than in open terrain. In amphibious landings, the radio became even more critical. Assault waves needed to coordinate with naval gunfire. Artillery units onshore needed to coordinate with ships offshore. The SCR-300 made this coordination possible. At Iwo Jima in February 1945, American assault waves landing on the beach carried SCR-300s that allowed them to coordinate with naval gunfire and with aircraft providing close air support. The radios enabled the assault to proceed with a level of coordination that would have been impossible with earlier communication technology. Japanese forces defending the island had no equivalent capability. They could coordinate within their immediate defensive positions, but they could not coordinate air and artillery support with their ground forces. The difference in communication capability contributed significantly to American tactical superiority across the Pacific. Japanese forces would be surprised by the speed and precision with which American artillery responded to requests from forward observers. Japanese commanders would be unable to shift reserves quickly because they lacked reliable communication with their dispersed units. The SCR-300 represented one of the most underappreciated technological advantages in the Second World War. It was not as visible as a tank or as dramatic as a fighter aircraft, but it was arguably more consequential. Every time an American artillery battery received a fire request and delivered shells on target within minutes, the SCR-300 was enabling that capability. every time an American airstrike arrived at a location identified by a ground observer. The SCR-300 had made that coordination possible. The radio illustrated a broader principle that would become increasingly important in modern warfare. The side that can process information faster, transmit information faster, and act on information faster will have a significant advantage. The Germans in 1944 understood this principle theoretically. They could see it playing out on the battlefield, but they could not match it because their industrial base could not support the necessary production. This became the core lesson of the SCR-300. It was not that Germany failed to try to develop equivalent technology. German signals officers understood the problem and understood what needed to be done. It was that trying was not enough. The gap between understanding a problem and solving a problem at the scale required for a global war was vast. The SCR-300 was mass-produced. The United States manufactured tens of thousands of them during the war. Every American infantry company had at least one. Many had multiple radios. The production was sustained throughout the war even as American industry was ramped up to unprecedented levels. No other nation could have matched this production rate. Germany attempted to match American military production in various categories: tanks, aircraft, artillery. In every case, the gap in production capacity was decisive. Germany would design a superior tank, but America would produce more tanks. Germany would introduce a new aircraft, but America would produce more aircraft. In the case of the SCR-300, Germany did not even get as far as designing an equivalent radio before the war ended. The aftermath of the war saw the SCR-300 preserved as a historical artifact. Veterans who had carried the radio, who had depended on it for their survival, treasured examples as reminders of their service. Military museums displayed the radios as examples of American technological superiority. Engineers studied the design as an example of effective military engineering. The radio represented not just a technological achievement, but a conceptual achievement. American military planners had recognized that communication was a weapon. They had designed a radio specifically for tactical use. They had built that radio into American military doctrine and tactics. They had trained soldiers to use it effectively. The result was a military capability that was greater than the sum of its parts. This is the enduring lesson of the SCR-300. In modern warfare, communication is not peripheral. It is central. The military that can communicate most effectively will be able to coordinate its forces most effectively, concentrate firepower most effectively, and respond most rapidly to changing circumstances. The SCR-300 gave American forces that advantage in World War II, and that advantage was decisive. The radio also illustrated the limits of individual technological advantage. Germany could capture an SCR-300 and study it and understand how it worked. But understanding one radio did not close the gap when America was producing thousands of them. Having the design was not enough when production required industrial capacity. Germany did not possess. This principle would repeat in subsequent conflicts. The United States would possess technological advantages that other nations would attempt to match. Sometimes they would succeed. Often they would find that matching the technology was easier than matching the production. And the doctrine built around the technology. The SCR-300 was the prototype for this pattern. In the decades following World War II, communication technology would continue to evolve. Radio communications would be superseded by more sophisticated systems. Satellites would eventually enable global communication. Digital networks would replace analog radios. But the principle that the SCR-300 had demonstrated remained valid. Superior communication creates superior command and control. Superior command and control creates superior tactical effectiveness. American military planners understood this. Investment in communication technology became a priority in every decade after the war. The Cold War competition with the Soviet Union was partly a competition in communication technology. The wars in Korea, Vietnam, and the Middle East all showed the continuing importance of communication capability. The SCR-300 had been replaced by more advanced systems, but the concept it represented tactical radio communication. Enabling rapid coordination of distributed forces became foundational to modern military operations. When you see a modern military unit operating with apparent seamless coordination, when you see airstrikes arriving at a target identified by ground forces, when you see artillery responding within minutes to a request from the front lines, you are seeing the spiritual descendant of the SCR-300. German officers who survived the war understood this. They had seen the American advantage firsthand. They had watched American artillery arrive with precision and speed. They had observed American air support responding with coordination that seemed almost magical compared to German capabilities. They had understood that communication was the key to that advantage, and they had been unable to match it. The irony is that the Germans understood the problem clearly. German signals officers had submitted reports explaining exactly what the SCR-300 could do and why it was superior to German alternatives. German high command had understood that matching American communication capability was important, but understanding and solving were separated by an industrial gap that could not be closed. This became the broader lesson of the German defeat. Germany lost the war not because German soldiers fought less bravely, not because German officers were less skilled, not because German engineering was inferior. Germany lost because American industrial capacity was overwhelming. America could produce more of everything: more tanks, more aircraft, more artillery, more ammunition, more radios, more of everything. The SCR-300 was part of this broader picture. It represented one category of advantage in a competition where America possessed advantages across virtually every category of weapons production. But it was an important advantage because it enabled the effective coordination of all those other advantages. Thank you for watching this story of how communication technology shaped modern warfare. If you want to support our video, please like and subscribe. Share this video with fellow history enthusiasts. Leave a comment below. Tell us what aspect of military communication interests you most. Join our community of thousands from around the world who are discovering the engineering stories behind history's greatest conflicts. The SCR-300 may have faded from memory, but its legacy shaped every modern military. Thank you for helping us keep these stories alive.